Hi students, hope you all are fine. Okay, so today we continue with the chapter electric charge and fields. However, today the class will be based on entrance topics. Okay, so we have found till now that electric field due to point charge, that is for board syllabus also. Okay, if you have a point charge plus q, then electric field at a distance r, what is the magnitude? 1 by 4 pi epsilon naught, the value of the source charge in magnitude divided by distance of the source charge from the point. And P is called what point, if you remember? Observation point. Meaning that is the point where we want electric field. So here we write R square. Okay. Now, direction of electric field, how do we decide? If the source charge is positive, electric field at this point will be away. Okay, and if it is negative, electric field will be towards. So this much you have to remember for understanding today's class. Now today we want to take different kind of source charge. This is for point charge. But what if I have a line charge? What if I have a ring of charge? Okay, so all those topics we want to cover today. Uh, to find that, you have to remember something in first PU which we have taught, and that is called integration. So before I continue, let me just quickly revise the main formulas which are present in integration and how to use integration in problems. Okay, so imagine students that y is some function of x. When I say y is a function of x, it means if x will change, y will also change. So y could be pocket money, x could be father's salary, right? So when father's salary change, usually the pocket money also should change. Okay, if the father is good only. Okay, so again, so y is a function of x. So in mathematics we write this way. So example could be y equal to x square. So when x is 1, y is 1. When x is 2, y is 4. So we can say y is a function of x. Okay. Now, suppose you integrate some function. Suppose you integrate. This is the symbol for integration. Basically, it means adding. Okay. So if you integrate f of x dx, then you will get some other function, g of x, let us say. This is some other function. Example is I hope all of you know integration of x power n dx is what? X power n plus 1 divided by n plus 1. So this formula should be memorized. Okay. So here in this formula, what is f of x? This, right? So this is your function of this function. And what is this? This is a different function, right? Compared to this. So this is your g of x. Now there will be sometimes limits a, b. So if there are limits, what you should do? Put here some square brackets and write upper limit, then lower limit. So after you use this, after you find the integration of f of x using some formulas, then put upper limit in place of the variable, minus put lower limit, this a in place of the variable. Okay, so this is how we do integration. So let me quickly show you one example. Suppose I want integration of x dx from 1 to 3. So what is the answer? What is the power here? 1. So use the formula. If this power is 1, what will be the answer? X power 1 plus 1 divided by 1 plus 1. That will be x power 2 by 2. So integration of x dx is x squared by 2. Then since limits are there, you show one square brackets. Here you write upper limit, here you write lower limit. Then you put upper limit 3 squared by 2 minus put lower limit 1 squared by 2 in place of the variable. Put upper limit, then minus sign will come, then put lower limit. Then you can simplify, right? So that will be the answer for this question. So these topics are covered in first PU already. If you remember, we have done derivation of s equal to ut plus half at square, v equals to u plus at using calculus method also, right? So this was your calculus method. Again students, if you really want to know what is integration actually and what it actually shows, how to use it, okay, in detail, if you want to know, then please put in the comment section. Then I will try to revise it in one of the videos. Okay, but this much you should know in order to continue the topic of electric charge and field, especially for entrance topics. So let us start with the first topic. So the first topic is I will give you a line charge. Line charge. Okay, so the charge is put in a line. What are the things I should give you? I should give you the total charge here. Total charge is capital Q. And the total length. Total length is capital L. And if you divide capital Q by capital L, that is called lambda. Just like if you divide mass by volume, what do you call it? Density. Similarly, if you divide charge by length, it is length. So we call it linear charge density, because we are dividing charge by length, not mass. If you divide mass by length, what do you call it? Linear mass density. This is linear charge density. And since you want electric field due to this distribution, you have to choose some point where you want electric field. That point is called observation point. So let me choose the point here. And how far is this point? Let us say it is at a distance A from this end of the wire. Okay. So question is find electric field at P. So P is your observation point. Fine. So let us see how to do this. Now we don't know the formula for electric field due to line charge. That is what we are trying to find. So how will we go? How will we start? We already know how to find electric field due to point charge. 1 by 4 pi epsilon naught Q by R square. Right? But problem is this charge is not point. It is not a point charge. It is a line charge. So what I will do? I will take a very small piece. A very small part here. A small piece in this wire I will take. And that piece I will say is at a distance x from this point. Now if this end is at distance x from this point, this length of the wire will be, this small length of the small piece will be what? Dx. Right? If this is x, this small distance will be dx. That is how we define dx. A small change in x. Okay, fine. Now students, look carefully. Though this whole charge is not point charge, this small part can be considered like point charge. Yes or no? So let us ask, what is the charge on this small piece? Charge on the small piece. Okay. Imagine you have apples. And I say each apple has same price. Then how will you find price of 5 apples? Think. Total price divided by total number of apples into price of 5 apples. If you want price of 5 apples, total price divided by total number of apples, that will give you price of 1 apple, into 5 apples will give you price of 5 apples. So same technique. So imagine the charge is distributed uniformly, because in order to apply that formula, that price of 5 apples is total price divided by total number of apples into number of 5 apples, right? 5 apples. So in order to apply that formula, what is important? Each apple should have same price. So similarly here, each dx, every part of this wire should have same charge. Then it means your charge is distributed uniformly. So in such cases, your lambda will be constant. Okay. So how will you find charge in this small part? Total charge, like total price, divided by total length, like total number of apples. There charge was price was changing with apples. Here charge is changing with length, right? So total charge by total length into length of this piece, dx. Okay, so I hope all of you understood how to find charge in this small part. So this is charge in 1 meter, and this is charge in dx meter. Okay, I hope all of you understood. See, if you remember, while discussing one of the previous topics in one of the videos, I have shown you that if lambda is constant, then whether you divide total charge by total length, or you divide small charge by small length, okay, dx you can take, then you will get the same answer, because lambda is constant, right? So if you cross multiply, you will get what I am saying. So there are many ways of understanding this formula. Okay, so now I know that this dq is charge of this small piece, and that small piece can be taken like a point charge. So the electric field produced by this charge at this point. Since it is positive, it will be away. And what symbol I will write? E, not E, because E I will use for total electric field due to the whole charge. Since it is due to a small part, electric field here also will be small. So how will we write dE? Right? So dE represents the small electric field produced by the charge in this small part. And to calculate that dE, I can use the formula of point charge. Okay, so which is 1 by 4 pi epsilon naught charge in this piece dq divided by r square. We used to write what was r? Distance between the source charge and observation point. How much is the distance from here to here? X. So x square. Some students may think, sir, how can you say x? Can't I write x plus dx? Well, dx is very small, I have told. So if you add x plus dx, you will get almost x only. So it doesn't matter, right? So while adding or subtracting, if one number is very small compared to the other number, you can neglect this number while adding or subtracting. Okay. So this is the electric field produced by this one, this charge. Now, how to find total electric field? You have to use superposition principle. So meaning you find electric field here now, you find electric field here due to this part also, then due to this part, then due to this part, then you have to add. What kind of add? Vector addition. But the good news here is this dq is also positive, so it will also produce electric field away. This dq is also positive, so it will be away. So since all the dq's will produce electric field away this way, all the vectors are in same direction. So you don't need to use root over formula, or you don't need to take components. You can simply add this electric field. Okay. So the total electric field is found by integrating, which means adding this dE, because all the dE's are in same direction. Okay. Okay. Once we have decided this, let us substitute. By the way, what is dq? I told dq is total charge by total length into dx. Now substitute this dE here. When you substitute in integration, constants can be taken outside. Why? Because integration means basically adding only, students. So if in school you remember, right, ax plus ay plus az is equal to what? A will be out because A is constant, A is common. So A will be out, what will be left? X plus y plus z. So when you substitute this dE here, constants you take outside. What are the constants? Q, total charge is constant, 4 pi epsilon naught is constant, total length is also constant. What is left? Dx divided by x square. X is not constant, right? Because you have to start from this charge, then this charge, then this charge, then this charge till you reach here. So your x will increase from this much to this much. So your x is changing as I go from one charge to another charge to find the electric field here. That was the whole idea of superposition principle. If I give you many point charges, how did we do numericals last time? We found electric field at a point by one charge, then due to another charge, then due to another charge. Yes or no? So same thing here also. Find electric field at P due to this dq, then this dq. But only the difference is here you have to do continuously. So since you are doing continuously, you have to use integration. Okay. Now, since now we know the variable is x and this is also dx, we can put the limits. So when you started from here, right, so from lower value of x, right? So when you start from this dq, what will be your x? X is distance between the piece and the point. So when you start from this piece, what will be x? See, a. So lower limit is a, and then you have to reach up to here. When you reach here, what will be x? See, L plus A. So L plus A. Right? Okay. So now we have to simply do the integration. So formulas already I have told you, right? So it will be E will be equal to Q divided by 4 pi epsilon naught L. This is integration of 1 by x square. So integration of 1 by x square, I can write x power minus 2. right? Lower limit is a, upper limit is L plus a. So this is your function now, f of x. So now you have to find the formula of integration of x power n. What is the formula? X power n plus 1 divided by n plus 1. So this is your new function. Limits are there, right? So you have to put bracket, upper limit, lower limit. Now what is this? X power minus 2 plus 1? Minus 1. Right? And what is minus 2 plus 1 here? Minus 1. Right? So if you now simplify this, it will become x power minus 1 is 1 by x. So the whole thing will become minus 1 by x. So once we have done the simplification of the integration part, now you put the limits. So if you put the upper limit, what will be the electric field? Electric field is Q divided by 4 pi epsilon naught L. Put upper limit in place of the function, okay, in the variable. So it will be minus 1 by L plus A. Then put minus sign from the formula. Then put lower limit in this function. So the function is minus 1 by x. Put lower limit. So 1 by A. Right? So visible? Right. So this will be equals to Q divided by 4 pi epsilon naught L. Right? So this will be minus 1 by L plus A plus 1 by A. Minus minus is plus. Then you do the simplification. So in the denominator, you can take LCM, right? So electric field will be Q divided by 4 pi epsilon naught L. So this LCM will be A into L plus A. L plus A, L plus A cancel, minus A plus A cancel, L plus A. So once you have done the LCM, minus A plus A will cancel. So what will be the final electric field? So final electric field is Q divided by 4 pi epsilon naught L, L divided by A into L plus A. Right? This L will be left, and you can now cancel this L also. Okay? Right? Okay. So this is epsilon naught. Okay? Epsilon naught. And this is L. This L will cancel with this L. So once you cancel the L, the final formula will look Q divided by 4 pi epsilon naught A into L plus A. Okay, so this is the result. So try to remember the result. Quite simple. Now you can also write this result in terms of lambda. What is lambda? Linear charge density. So here I wrote in terms of charge. So what is charge? If you cross multiply lambda into L. So you can also write this as lambda into L. So either you can write this way or you can write in terms of charge. So this is the formula. So if I give you the distance of the point from one end, if I give you the length of the wire and the charge on the total wire, then you can find the electric field at any point in this line. Okay. Now let us do second problem. So this is the first topic which I wanted to do. So you can see the formula for electric field will not be always 1 by 4 pi epsilon naught q by r square. It is only for point charge. For line charge, so if this is your line charge and if I ask you here in this line, then the formula is completely different. You have seen it. And if I ask somewhere here or somewhere here, it is more difficult. Okay, so which we will see later. Now we will do a very interesting one. Okay, second one. So I will give you a before was line charge. So this is ring of charge. Ring of charge. So imagine I give you a ring of charge like this. Okay, so this is my ring of charge. So imagine I have kept it this way. Okay, and the charge is positive. You can take. Okay. Now what should I give you? Total charge is Q. Now length no need to give. You can simply give the radius. So radius is R. So radius is R. Total charge is Q. And if you want to write in terms of lambda, how will you write? Total charge by total length of this. Length of circle is what? 2 pi r. You can write in terms of lambda also. Now where I want electric field? I want electric field along the axis of the circle. So if this is a circle, okay, if this is the circle, okay, this is called axis. A line passing through its center and perpendicular to its plane. So this line is called its axis. So I want electric field at some point in this line. Let's say this point. So P is my observation point. So how to do this? Again, same trick. This is not a point charge. So you will not be able to find electric field here by using the formula of point charge. But you can imagine this is made up of many small pieces. So let me take a small piece. Piece here means part. And the charge on this part, let me write dq. Okay. Now, what will be dq? Already we have told dq will be total charge by total length. Total length is 2 pi r into dx. Yes or no? Okay. So that will be your dq. Now I want distance from source charge, which is dq, to observation point. So let me call this as, you can write anything you want. Let us write r. Okay. And let us say distance of this point from the center is x. Okay. So let us now find what will be the electric field here. So electric field here, direction will be where? Direction will be, since it is positive charge, it will be along the line joining the source charge and the point. It is positive, so it will be away. So this will be your dE. What is dE? Electric field produced by this small part of the charge, which I am calling dQ. What will be the formula for dE? Since it is point charge, small part can be taken as point charge. So dE will be 1 by 4 pi epsilon naught dQ divided by distance from here to here is r square, right? Now this r square, you know from Pythagoras theorem that this r square you can write r radius square plus this x square also. So if I substitute here, what will I get? R square plus x square. Okay, fine. Now to find the total electric field, previously what I told, integrate dE. Am I allowed to do now this part? Yes or no? Am I allowed or not, students? Think. When are you allowed to add the magnitude of vectors to find the resultant vector? If one vector is here, like this, another vector is also here, like this is A, this is B, then total is A plus B. But if it is like this, then you cannot say resultant vector is A plus B. Then we use what formula? Root over A square plus B square, like that. So here you cannot, you have to first check whether the dE produced by this charge and other charges, are they in the same direction? In the previous topic, all the dE produced by different charges were away and they were in the same line. They were in the same direction. Remember, right? So we added. But now can we do? Let us check. If you take another charge here, let us say, you can take anywhere, but let us take here. Then this will produce electric field this way. This way. Yes or no? Due to this part, electric field will be away. So clearly, students, you can see they are not in the same direction. So due to this, it will not be in same direction. So how it will look? It will look something like this. Like this, right? Yes or no? Because due to this is here, due to this is here, due to this part it will be there, right? Due to this piece, that side. It's a ring, right? So electric field will be like this, like this. So electric field here will be looking like this. So from where you see, it looks like this. But if you see from this side, like this, okay, then you will see like this. So they are not in the same direction. So you cannot simply add the magnitude of electric field. So what we will do, here comes the knowledge of vectors. So you have to take components. So let us say this is theta. Then what will be this angle? Theta. And by symmetry, you know this is r, this is also r, so this also will be theta. then this is also theta. And you know from first PU knowledge that any vector A bar will have two components, right? And if I say this is theta, this will be your A cos theta component and this will be your A sin theta component. If here is your x-axis, then we also write this as A x component, right? And this we write AY. So these things you have studied in projectile motion in first PU also, right? So we will do the same thing, okay? So let us take components of this DE. So it will be here one component DE cos or sine. Theta is here. So this is the adjacent side. And adjacent side will always have cos. That's why cos is defined as adjacent by hypotenuse. And another component of this DE will be here. That will be DE sin theta. Same way, this DE will also have two components. One here, DE cos theta, and one here, DE sin theta. So what did you learn from here, students? If you look carefully, this component and this component are both DE sin theta. Magnitudes are same, but direction is opposite. So these components will cancel. And what are in the same direction? DE cos theta. So this is for only these two pieces. If you do for all the pieces, okay, for all the pieces, if you repeat this, what will you find? All the DE cos theta, this component, all of them will be in same direction. So what you should integrate, matlab what you should add is not DE, you should add DE cos theta because all of them are in same direction, right? Okay, let us substitute now what is DE. DE is dq divided by 4 pi epsilon naught, and this is what? R squared plus x squared, right? Yes or no? Yeah. And cos theta. What is cos theta? I can also write cos theta here as adjacent is x. Hypotenuse is this small r. And what is small r? R square is this. So r will be root of r square plus x square. So I can write root of r square plus x square. Right? Okay. Now you will be thinking, sir, why you are not putting limits? See, I am starting from this charge and I have to come like this, like this, like this, like this, like this till I reach here. So when I do that, any constants can be taken outside. So let us see which are the constants. I heard some of you saying, sir, don't drop, we have not written like that. Okay, you can pause the video, ma. This is video plus. Okay. So now constants you can take outside. Now during this was the circle, right, in which I am moving from this dq to this dq, this dq, this dq, like that. I have to find electric field due to all these dq's. Now here, what are the constants? X, will it change? X was what distance? This distance. So whether you choose this dq, this is x. If you choose this dq also, that will be x. So this x will not change. Will the radius change? If you come to this also, this radius only, this is also r only, this is also r only. So r will also not change, x will also not change, meaning everything will come out. So constants all will come out. So what will be left? Here x will come out, 4 pi epsilon naught will come out. Now this part you see, if I multiply a into root a, what will you get? Root a means power half. Okay, root a means power half. What is the power of this a? 1. So power 1 here, power half here, and you know the formula of x power a into x power b, x power a plus b. So you can add the powers. If you add the powers, what will you get? A power 3 by 2. So remember this, okay? A into root a is a power 3 by 2. So r square plus x square into root of r square plus x square. That will give you r square plus x square power 3 by 2. So everything is constant. So what will be left? Only dq. Don't take dq also out. Then what will you integrate? Nothing. Huh? Now if you add dq, so dq was what? dq is scalar, remember. So all these dq's are positive. So this dq, this dq, this dq, this dq, 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 this dq, this dq, this dq, this dq, this dq. If you add all the dq, what will you get? Total charge. So I can write now in place of integration of dq, I can write total charge. And this is the formula for electric field at a point P, which is at a distance x from the center of the ring of charge. Okay, and direction, if it is positive everywhere, if it is a positive ring charge, electric field will be this way, right? Because you know that only dE cos theta was this side. Remember, dE was here, dE cos theta was here, and dE sin theta was here. We saw that dE sin theta will cancel, and dE cos theta will add. So the total electric field will be this way, from center to the point away. Okay, fine. Now let us do more things. Okay, with this formula, many other things can be asked. Okay. So now let us ask what will be the electric field at the center of the ring of charge. So this is topic 2 only, or topic 2 sub A. Okay. So I want to know at the center of the ring, at the center of the ring of charge. So this was your ring of charge, right? This was your ring of charge. This is electric field where at a distance x from the center at some point P along the axis. Now suppose I want at the center, means I want here. So if this P is here, what will be x? Right now this is x. So if this P comes here, what will be x? 0. So at the center of the ring, x is 0. And if x is 0, this will be 0, but this numerator will be 0. So what will be electric field? 0. And it is expected also, because if I now show you the ring like this, then at the center, due to this positive charge, it will be away. Due to this, sorry, here I should show away. Due to this positive charge, it will be away. So due to this positive charge, it will be away. Due to this positive charge, it will be away. So like this, you can see they will cancel. Okay, so at the center, x is 0. So electric field at the center of the ring is 0. So remember this. Now tell me another case. So this is 2. Okay, sub B. Okay, second concept. My question is, what if my ring is very small or the point P is very far from the ring? So if my P is very far, what will happen? Again remember, this is your x, this is P, this is R. So if P is very far, then this x will be very large compared to the radius. So if x is very large compared to the radius, what will happen? Then this x is very large. So in the denominator, r square plus x square can be approximately x square, because x is very large, right? So this formula will become E equals to x into q divided by 4 pi epsilon naught. R square plus x square will become simply x square. Power, what's the power? 3 by 2. So this power and this 2 will cancel. So you will get x cube. Here what will you get? X cube. No, this 2 and this 2 will cancel. X cube. And here there is one x. So formula will be q divided by 4 pi epsilon naught x square. It's a nice formula. This formula is, oh, this is formula for what charge? Point charge. Obviously, see, if your observation point is very far, if you are very far, and if you from very far distance, if you look at the ring, it will look like a what charge? Point charge. So the formula will also look like formula of point charge. Okay. Now let us try to draw a diagram, a graph to show the variation of electric field along the axis of a ring of charge. So this is 2 part C. So I have given you a ring and there is charge on the ring, and this is x equal to 0 point, this is positive x, this is negative x. Okay, so as I move on this, I want you to show me a graph of electric field versus okay, so how will the graph look like? So this graph has come in one of the JEE exam. Okay, so you have to think how the graph will look like. So at the center, x equal to 0 means center point, no? So at the center, what was electric field? Go back and check, it was 0. So the graph will start from here. And when x is very large, what was the electric field? When x is very large, it was 1 by 4 pi epsilon naught q by x square. So it is 0 here. Then as x increases, this should decrease. Now from 0 you can't further decrease, right? Because this is magnitude. So that means on this side the graph has to go up and then it has to come down and then decrease. Right? Because you know it is 0 at the center and it is 0 as, because if x becomes infinity, if x is very large, then also electric field will be 0. So the graph has to go up and then down. Okay, on the right side. And here electric field here is this way, right? Away. And this will be this way. You don't have to repeat for this part. You have to write same formula. Only thing is, if this direction is taken positive, this direction will be negative. So you can show the direction. So same graph but in the negative x-axis. Like this. Okay. So this is how the graph of electric field looks like. So it is very clear that at some distance, which I don't know, which I want to find, at some distance from the center, matlab somewhere here, your electric field will be maximum. Because it is center at the, see, it is 0 at the center, it is 0 when you go very far also. So in the middle it has to be somewhere maximum, because it starts from very small, then it becomes something, then again it decreases and becomes 0. So it must have some maximum value. So question is, at what distance from the center? What should be x? At what distance from the center will the electric field be maximum? So this I will give you as a homework. Okay, so this also has come in JEE. Okay, how to find? I will give you a hint. So before I give you the hint, let me remind you about dy by dx. So what is dy by dx? Okay, differentiation you are doing, I suppose, in mathematics. So but that is formulas and all you are doing, right? But what about the meaning of dy by dx? What does dy by dx represent? It represents slope of tangent at a point. Slope of tangent at a point. Meaning, see, y is some function of x. I told you before, y equal to f of x, right? So imagine my y is here and my x is here and the graph looks like this. Then you know, at this point, if I ask you to draw a tangent, how will you draw the tangent? This way. Right? Let me change the pen. How will you draw the tangent at this point? Like this. And that time, what will be the slope? Tan theta. So this slope is nothing but tan theta. So this will be your theta. So slope will be tan theta, which is dy by dx, which is positive, right? Because theta is acute. So for acute angles, slope is positive. Similarly here, if you draw tangent, theta will be obtuse. So slope will be negative. What about here? Think, if you draw tangent, it will be like this or not? So if it is like this, what is the angle made with x-axis? No angle, because it's parallel. So the angle made by this tangent with this axis is 0. So if angle is 0, what will be tan of 0? Tan of 0 is 0. Sin 0 by cos 0. Sin 0 is 0, cos 0 is 1. So 0 by 1, 0. That means at this point, your dy by dx must be 0. Understood? So just let me clarify one small thing. Let me write it down. So please remember, students, that whenever you have a function y, which is a function of x, and if the graph looks like this, then at the point x equal to something, x naught or whatever, when y is maximum, at that point your dy by dx must be 0. Okay, so same thing we are finding here. We want to find the x, which is distance from the center, where we calculate electric field. So E is our Y here, right? So we want to know at what X will E be maximum. So what you should do? Simple. Here your dE by dx should be 0. And E you already know formula. Q divided by 4 pi epsilon naught r square plus x square power 3 by 2 into x, right? So you can see one function is x, other function is this. So I hope in mathematics you have learned how to find differentiation for ratio u by v formula. So apply that formula and take differentiation of this. So put this e here. Constants you can take outside, okay, and then if you divide by 0 on the right side it will become 0. So just simplify, just put this e here and then do the differentiation, and you will see you will get x equal to something, and that is the answer for the question what is x, so that electric field is maximum for a ring. Okay, so please do that part, and as I told you need to know differentiation. So I hope in mathematics you are doing that. If you don't get, in the next video I will solve it, but let me know, okay, please let me know. Okay, we'll further do more. Okay, so it's very interesting. See, we have taken one ring of charge, but so many things come from here, right? So now the next topic is, here I have a ring of charge, right? Ring of charge, and here is my axis. Let us say I keep a negative test charge here, minus q naught here. This is total charge q, radius is r. Okay, what is the force on that minus q naught? Force on minus q naught. What will be the force on this? I told you, once you know electric field, what do you know? Force on 1 coulomb. So if you want to find force on q coulomb, what you should do? Q into E. So already we know electric field here. So it will be q naught into E. Minus if you put, then put better sign. So what will be the force? 0. Why? Because at the center, what is electric field? 0. So 0 into q naught, 0. Meaning this charge right now is in equilibrium, like a pendulum, right? So when you keep a pendulum like this, your mg is balanced by tension. So the net force is 0. So just like this pendulum is in equilibrium, this minus q charge is also in equilibrium. Now think, if I displace this minus q slightly, solve x. So x is very small. So if I put minus q here now, will the force be 0? No, because electric field here is not 0. So why will the force be 0? And where will be the direction? Since it is minus q, see, imagine here, this is plus charge and this is minus q. So minus q will be attracted here, will be attracted here. So resultant will be where? Here or not? So minus q will be attracted this side. Understood? Why? Because see, if you remember the force on, see, here only you can understand, see, this is minus charge. So force is opposite to electric field. Where was the electric field due to this ring of charge? This way, remember. So if electric field is this way, where will be force? This way. So the moment you leave this charge will come, it will accelerate this way. Just like this pendulum. The moment you displace the pendulum and you leave it, what happens? The pendulum comes back. So once you take it here and then you leave this, once you take it here and then leave, it will feel a force this side. So once you leave, what will happen? It will come this way, it will accelerate, and as it keeps accelerating, it will move faster, 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 till here it will move faster, till here. Once it goes this side, so once your minus q comes this side, force will be now this way, right? So net force will be this way, this side. So imagine you are running this side, but force is this side. What will happen? You will move faster or slower? Slower. You are running this way, wind is coming this way. So that wind will hit you, will exert a retarding force. So you will slow down. So now this minus q, as it is going this side, will slow down and stop. Then again this force will bring it back. Matlab, this minus q will start oscillating, just like this pendulum. So now I am interested to know what is the time period of oscillation. So let us remember in first PU how we did. We found the acceleration. Okay, And if you remember, it was minus g by L x, something like that. X was the displacement. How much displacement you have given from the equilibrium position. And then once you write this, what is your acceleration equals to formula? Minus omega square x. Right? Your acceleration formula is minus omega square x. So by comparing, omega square will be g by L. So omega square will be g by L, omega will be root of g by L. So same thing we would like to do even in this topic. So what we have done is we have given a small displacement to this minus q, which was initially sitting here. So it was in equilibrium. So I give it a small displacement. Once I give it a small displacement, I want to calculate the force. So it will be minus q naught into E. Let us remember what was the formula for E. Let us write only magnitude. Okay. So what was E? Qx divided by 4 pi epsilon naught r square plus x square power 3 by 2. Right, just now I did. Now, clearly right now if you see, force is not proportional to x right now, because there is x square also. Here also variable is there. Here also variable is there. So let us keep x very small. If you keep x very small, what you can do? R square plus x square. This can be written simply as r square now. Why it can be written as r square now? Because x is very small. Understood? Large plus small is large. The small can be neglected. So if x is very small, if you give it a small displacement, if you remember even in the case of pendulum, the teacher will always say displace the pendulum only little so that it performs simple harmonic motion. So if your x is very small, then while adding, not while multiplying, okay, while adding, x can be neglected. So if you neglect the x, what will be your force now? Tell me. Q naught q x divided by 4 pi epsilon naught. This is neglected. R square power 3 by 2 will be r cube. So we found the force. After finding the force, you find the acceleration. And to find acceleration, what will we use? Newton's second law. So acceleration will be force divided by mass of this particle. Right? So force is q naught q 4 pi epsilon naught mass r cube x. And you can see, students, that this is constant. That means if I compare this with our formula of simple harmonic motion, A equal to omega square x. Minus is there, but I am writing magnitude. So omega square x. Then what will be your omega square? See, acceleration. Right? This is x, this is x. So what will be your omega square? This quantity. So let me rub this now. So I have understood that if a negative test charge is kept at the center of a ring of positive charge, then the force on that negative test charge is 0. And if you slightly displace it from its equilibrium position, it will come back. And as it comes back and it crosses the center, it will slow down and it will stop. Again, because of the force, it will come back. So this motion will keep occurring like in the case of pendulum, and therefore it is nothing but a simple harmonic motion. And once you know it is simple harmonic motion, you know in first PU the acceleration in simple harmonic motion is given by omega square x. So if we compare this formula, so by comparing, what will be your omega square? Q naught q divided by 4 pi epsilon naught m r cube. Okay, so omega will be root of this. And once you know this is omega, what will be the time period? Time period of oscillation. So time period of oscillation formula is 2 pi divided by omega. So if you divide 2 pi by this omega, if you divide this, denominator will go in the numerator. 4 pi epsilon naught m r cube divided by q naught q. And if you want frequency, then you just take ulta, because frequency is 1 by time period. Okay, students. So So we have done many things with this ring of charge. So please try to revise. It is not important for board syllabus at all, these topics. But in entrance topics, this is very important, especially for JEE. Okay, for NEET, at least you try to memorize the formula and try to memorize at what distance from the center your electric field is maximum, so that they can very much ask. So now we will see electric field produced by a line charge, but at some other point. Okay, so in the first topic we did electric field due to line charge at a point which lies on the axis of this wire. Okay, so if you have a wire which is charged, okay, uniformly, then we know what is the electric field produced at this point, right? So if this is A and this is L and the charge here is Q and lambda is charge per unit length, then we know how to write electric field here, right? But now we will see the formula for electric field due to line charge. So this is our third one. Okay, so I will give you line charge like this. Line charge. Okay, so total charge is Q, total length is L, which means lambda will be total charge by total length. And now I want electric field at a point uh, at which is at the bisector of this line. Okay, matlab find the midpoint and go some distance. Here I want. So not here or here. Okay, so you cannot use the formula of the first topic. So again students, we will not be doing derivation for all distribution, then it will take lot of time, and since these are entrance topics only, these are entrance topics, so anyways we don't need to do the derivations as such, we just need to remember the result properly. So we need to remember for this kind of distribution, this is the formula for electric field. So we have to write the electric field formula 3 4 times, 10 times, 20 times, and memorize it with the meaning of the symbols also. And also you should know for this kind of distribution at this point, this is the formula. So I will give you the formula, and how will you remember the formula is simple. You just apply the formula more number of times in numericals or problems, or entrance based problems, then you will remember the formula, right? So it's like in your school days there was a formula called simple interest, right? Principal into rate into time divided by 100. You don't know the derivation of that formula, but still you remember the formula because you used it because you used in many problems. So formulas which derivations are not given, you need to apply the formula more number of times in different problems so that you will remember it easily. Okay, so let me tell you what will be the electric field at this point, which is at a perpendicular distance r. So what is r? Perpendicular distance between the wire and the observation point. Before I tell you the formula, can you tell me in what direction the electric field should be? Can you tell me the direction? You can see these plus charges will produce electric field this way. But for every charge here, there will be a charge here which will produce electric field this way, right? Example is, suppose I take one charge here, plus, then that will produce electric field away, dE. This, for this charge, there will be one charge this side, that will produce electric field away. And you know, these two will have resultant electric field in what direction? This direction, right? You can break this into two components. So this component will add, this component will cancel, right students? So it is very easy to know that since this point is in the bisector, matlab in the middle of this wire, passing through in a line that passes through the middle of this wire, middle. So it is obvious that this side whatever charges are there, they will produce electric field this way, and for every electric field this way there will be an equal electric field this way, so the total will be this way. So first thing is to know the direction, which we have found, right? Once we know the direction, then the formula is given by lambda divided by 2 pi epsilon naught r, this is the r, into sine theta. into sine theta. Okay, so we can write sine theta nearby. So what is lambda? You know lambda is the total charge divided by the total length. What is r? This distance, perpendicular distance. So the only thing you should know is this theta. So what is this theta? This theta is the angle subtended by the ends. So from the ends of the wire, you draw these lines to the observation point. Then this angle is your theta. Can you take this angle? Yes, because both angles are same. So this angle is either this or this, not this angle. Huh? This is 2 theta, right? I want only theta. Okay, so this is the formula. So let us apply this formula in one question. Okay, suppose I give you a line charge. Okay, application. This is application. Okay, application of this formula. First question. Imagine this line charge is going from infinity, from it goes up to plus infinity to minus infinity. So it is a very long wire. Then you take any point, you can say that is the midpoint of this part and this part, because this side is also up to infinity, this is also up to infinity. Any point you choose, doesn't matter. Then electric field will be always, direction will be this way at this point. Okay, this is r and it has charge and the linear charge density is lambda. Then what will be electric field here now? Lambda divided by 2 pi epsilon naught r, this formula theta. Now what will be theta? See, theta is this angle. Now when here what happens to this end? It goes up to infinity. This also goes up to infinity, right? Okay. So if this end goes farther and farther, this line will go like this or not? This line, see. Suppose I take this end farther. Okay, then the length will be longer and this line will become like this. Correct now? So as you take this end, if you move this end farther and farther, this line will become like this, like this. So ultimately when this end goes to infinity, this line will become parallel to this line. Okay, you know that parallel lines meet at infinity. Super, right? So if this end goes to infinity, then this line will become parallel to this line. In that case, what will be theta? If this line is parallel to this line, what will be this angle? 90 degrees. So in this application, what is theta? 90 degree. So this will be sine 90 degree. So what will be electric field? Lambda divided by 2 pi epsilon naught r. Okay. Sometimes people write this formula 2 lambda they write and here they write 4. Okay. Why? Because while substituting values, if they give 1 by 4 pi epsilon naught, we know the value. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. So either you write lambda divided by 2 like this, or you write 2 here and write 4 here. It is the same thing, right? 2 divided by 4 is 1 by 2. So please write this formula 10 times, 20 times in a notebook with this diagram. Without diagram, there is no use of writing the formula. Oh, with diagram, if you write, then you will know that for this kind of distribution of charge, this is the formula for electric field. Okay. And what if that line charge is a infinitely long line charge? If it is infinitely long, then this theta will be 90. So answer will become lambda divided by 2 pi epsilon naught r. Okay. Let us apply this formula now to another question. Okay. So second question is, you have a line charge which is infinitely long. Okay, infinitely long, and this has got positive charge and lambda is the linear charge density. Now what I am doing, I am sending an electron this way. I am throwing an electron this way. Okay. Now let us see what happens to this electron whose velocity is inside the boat. Okay, it is going perpendicular to this boat. Now you know electric field due to plus charge at any distance r is this way. Electric field is this way, yes or no? I have shown you here, diagram I have shown you, right? So direction of electric field is this way. Now if you put here a negative charge, electron's charge we write minus E, right? So that electron, since it has negative charge, I have already told it will feel a force this side. Because if the charge is negative, force will be opposite to electric field. Right, students? Please see the topics which we have covered already. So the force will be this side. So this electron will feel a force this side. So it will turn like this, right? Yes or no? If you throw a chalk like this and gravity force is down, then it turns like this or not. But the beauty of this is as it goes that side, okay, as it turns and goes that side, electric field that side of the board will be where? Away from the board. So force will be towards the board. So it will again turn. So basically it will move in a circle. Okay, let me try to explain it even more nicely. Okay, so to understand this even more nicely, try to see from this part, from this top. So imagine this is your eyes, big eyes I have shown. Huh? So if you see from here, then this line will look just a dot, no? Dot it will look like plus charge. Yes or no? This is the line charge, right? If I see from the top, I will see only this part, right? If I see like this. Yes or no? So this is the line charge like this. From here if you see, okay? This is from here if you see. Now, electric field here is this way, right? So from here if I see, electric field I will see this way, right? Okay. What about here? Where will be electric field if I ask here? It will be this way. So it will be this way, electric field. What about that side if I ask? So electric field, if this is a line charge, electric field here is this way. Here it will be that way. Here it will be this way. So it will be basically like this, electric field. Understood? It will be in a way radially outwards, but not in all direction. Okay, so only like this. Okay, so if this is the line charge, okay, is it visible? Yes, like this, like this, like this, okay, like this, everywhere. So if you see from the top, you will see electric field lines like this. These are your electric field lines for a line charge when you see from the top. Okay, so from side if I show you, everywhere if I show you electric field, it will look like this. Okay. Now I told you I'm throwing an electron this way, right? So this way means from the top if you see, from the top it will look this way, right? So from top if you see, you will see electron going this way with some speed. So as it is going with that speed, force on the electron's charge is minus, remember. So force will be opposite to electric field. So force will be this side. Similarly, when it will reach here, force will be this side. When it will reach here, force will be this side. When it will reach here, force will be this side. When it will reach here, force will be this side. When it will reach here, force will be this side. When it will reach here, force will be this side. So like this, the forces will act on the electron, which means the electron will move in a circle. And this force is acting towards where? Center. So they will ask you, find the radius of this circle, or they may ask you the speed. Let us see what we can calculate. So since it moves in a circle, we know that anything which moves in a circle needs a what force towards the center? Centripetal force. In case of Earth, gravity will provide the gravitational force of Sun provides the centripetal force to planets. Similarly, when a car makes a turn, friction provides the centripetal force. Here, which force will provide? The force on electron due to this electric field. So the force due to electric field, this force will provide centripetal force. Centripetal force, right? Okay. Now, this is in magnitude, okay? So what is the magnitude of the electrostatic force? Q into E. Because we know how to write, don't write 1 by 4 pi epsilon naught, that formula, Q1, Q2 by R square. That is for point charges. Here the charges is this line charge and this electron. So the force on this electron due to line charge, we are writing here. And how to write the force? Forget about the electron, find the electric field, which we know already. Once you know the electric field due to this line charge, multiply with the charge of electron. in magnitude, okay, and that will provide centripetal force. What is the formula for centripetal force? mv squared by r. Yes or no? And for electron, how do we write the charge? In magnitude, E we write, no? 1.6 into 10 power minus 19 coulomb. So this Q will be E. And what was the electric field due to this line charge? This line charge, lambda divided by 2 pi epsilon naught R equals to mv square by R. So one very beautiful thing you will see, R gets cancelled. So speed will be, bring this mass this side, E lambda by 2 pi epsilon naught m root. And the important point to note here is it is independent of the radius. So it doesn't depend on which, whether you throw it here or here or here, everywhere the speed will be controlled by the charge density of this wire and the charge of this particle. Of course, it depends on the mass also, but it does not depend on the radius. Okay. Now, so we have seen how to apply these formulas of electric field due to line charge to this question. Okay. Now, every time you may not be given a simple situation like that. So now let us do fourth kind of distribution. So again, I will give you line charge. Okay. Okay, let us do one more application. Okay. So this was third application. Okay, one more application for the same problem. So I may say this distance is, let us say this distance is 2a. Okay, this whole thing is 2a. See, in exam they can use whatever symbol they want. You cannot tell them. You cannot control that. Okay, and the charge is q. And I want electric field at a distance x. Here I want. Okay, so how will you write? Only in the options there will be only q, this a and this x. So the formula is what? Lambda divided by 2 pi epsilon naught this x. Yes or no? This was your r in the formula, but here they have given this as x. And here what we wrote? Sine theta. But sine theta is not there in the option. So you have to write, you have to substitute for sine theta somehow. So how will you do that? Look the diagram and remember what was theta. Theta was this angle. Remember, right? Or you can choose this angle also because this is passing through the midpoint. So what will be sine theta if you look the diagram? This is opposite side. This is your A and this is hypotenuse. It's root over a square plus x square. So I can write a divided by root over a square plus x square. So this is also correct. Understood? Okay. Now let us see the third kind of distribution. Okay. So in the third kind of distribution, this is fourth kind, right? Fourth kind. So just number the distribution properly, okay? Different kind of charge distribution we have taken, right? Starting was line charge. Remember or not? Line charge it was, and line charge and point was in this line. Here was the point where I want electric field. Then I took ring of charge. Here I asked electric field. Then I did line charge at the bisector here. Okay, perpendicular distance r. Here I wanted. This is your line charge. So this is the third one actually. So now we'll do the fourth one. So in the fourth one, again I will give you line charge, but slight change I will do. So this is the line charge. Okay. So I want electric field somewhere here at a distance r. And this total charge is q, total length is l, lambda is charge by length. So now if I ask here, can you tell me where will be the electric field direction? Will it be like I have told you till now? Will it be in the same direction like this, which I have told before? No, it will not be this side because you can see more charge is below this line. More charge is this side. So these charges will produce more electric field this way. So if this electric field is more and here less charge is there, above this line, less charge is there, so less electric field will be there. So total will be this way. It will not be this way. If it is like this, then total will be this way, according to parallelogram law. So now you have understood that the direction of electric field will not be this way. It will be somewhere here. Okay? And this is P. So this is the direction of electric field. So how to find this formula for this? Again, we will not derive, only we will try to remember. Now you know that if this electric field, if I say this is x axis and this is y axis, this E will have two components. Here one component, here one component, right? So this is your Ex component, this is your Ey component. This is the x component of electric field, y component of electric field. Now you have to write formula for these two separately. So what will be Ex? So if you remember, Ex like is your previous one, that if this point was in the middle, then the total electric field was this way, remember, and that will be your Ex. And in this case, what will be Ey? 0, because when this point was in the middle, there was no Ey, because the total electric field was along x-axis. And you already know, if a vector is along x-axis, y component of the vector is 0. Okay? So the formula for Ex is lambda divided by 4 pi epsilon naught. You have to write 4, you have to write. I'll tell you how to remember into r. So this part is almost same, but before there was 2 here, now I am writing 4. And here you have to write sine alpha plus sine beta. Okay, so this is the formula for this component. Now you will say, what is alpha and beta? These are angles, but which angles? So this angle it is. See, from this end you draw this line, and from this end you draw a line to the observation point. Then this angle is your alpha, and this angle is your beta, and this distance is your r. Okay, so now if you go back to the previous problem, in the previous topic, this was your line charge and your point was passing through the mid. The point was lying on this line, and this line was passing through the midpoint. So that time this angle and this angle was same. Do you remember? And both were theta. So so from here to here, how will you go? Simple. Both alpha and beta you write theta theta. So if you write theta here, what would be this? Sin theta plus sin theta will be 2 sin theta. So if this is 2 sin theta, this 2 and 4 will cancel. You will get lambda by 2 pi epsilon naught r sin theta. If the point was in the middle of this line, in the middle of this line charge. Okay, but not here, there. So I hope you understood how easily you can remember this formula by remembering this. Okay, so by mistake don't put minus or something, then your electric field will be 0. Now you need to know this component also, remember. So Ey will be lambda by 4 pi epsilon naught r, and here if you do the derivation, you will get cos alpha minus cos beta. Cos alpha minus cos beta, and alpha and beta are same. Okay, how cos comes? Again, for that we have to do derivation, which we will not be doing because it is extremely lengthy and it is of no use. We just need to know these formulas. But now once you know these components, what will be your total electric field? This E, you know, root over Ex square plus Ey square, right? Because if you add these two vectors, you will get this vector. That's why these two are called components of this vector, right? If you add this and this, what will you get? U, right? So what are these two? What are these two? Your components. And you know how to add two vectors when they are perpendicular from your vector addition root over x component square plus y component square. So calculate this, then calculate E. Now let us apply this formula in one question. Interesting question it is. Okay. So let me write the formula for y component also. Okay, simply I wrapped it lambda by 4 pi epsilon naught r cos alpha minus cos beta. By the way, if the point was passing through this line, passing through the midpoint of this line charge, then your alpha and beta will be same. Then this will be 0, right? If this is theta, what will you get? Cos theta minus cos theta. So y component will be 0. So there won't be any y component of electric field. All the electric field will be along x-axis. If you treat this as x-axis, okay? Now let us apply this to one sub question, okay? Application 1, okay? So imagine I give you a line charge which is infinitely long this side. So it is going up to plus infinity, but this is not going to infinity. This is here, and I want electric field here at some distance r. Here I want. This is line charge. So this goes up to infinity. So now this point is not in the midpoint, right? So this wire is basically infinite in this direction, but the other end is finite. It is here itself. It is not going up to infinity down. Then try to tell me what will be alpha and beta. So let us go back. If this is your line charge and you want electric field somewhere here, then what is the concept I told? This is your perpendicular distance, right? Then from here you draw one line, that is your alpha. From here you draw one line. Now this angle let us try to find. So this angle is what? From this end you have to draw a line to the observation point. But this end is where? Up to infinity. So if you draw a line to this point, that line will be parallel to this line I have already discussed before. So your alpha will be 90 degree. Okay. Then how to find this angle beta? This angle beta. From the other end you draw a line to the observation point. Then see what angle this line makes with this perpendicular distance. So from this point, from this end, if you draw a line to this point, that line will coincide with this perpendicular distance, meaning this and this will coincide. See here in this diagram, this line from one end of the wire, this is the end of the wire. From this end of the wire to that point we have to go now. So from this end you have to go to the point and you have to see what angle this line makes with this perpendicular distance. But here this itself is perpendicular distance. So this line and this line are same in this case. So beta will be no angle. No angle means 0. So once we have known this, what will be your x and y component? Let us check. So x component will be lambda divided by 4 pi epsilon naught r. Sine this is 90, this is 0. You know sine 0 is 0, sine 90 is 1. So this is your Ex. What about your Ey? Lambda by 4 pi epsilon naught r. Alpha is 90. So this is 90. Beta is 0. 0. So cos 90 is 0. And cos alpha is 90. So cos 90 is 0. Cos 0 is 1. So this will be minus this, right? So that means electric field here will be y component is, so let me show the direction this side. So this is your line charge. This one goes up to infinity and this is here itself. So I want electric field here, right? So x component is positive, matlab this side. And y component is coming negative, matlab this side. And it should be there itself because see, above this there is positive charge, no? So total will be this way. So total electric field will be in this direction. And since both of them are same, this and this are same, this angle will be 45 degree. This is the total. So I just told you how to find total electric field. Root over this component square, Ex square plus Ey square. But you know both are same. I mean minus sign is there, but when you put this minus here, square will be plus only. So if this is x, or if this is, I don't know, a, let's say, and this is minus a, if you substitute here, what will you get? A square plus minus a square, that is plus a square. So you will get root 2 a, that means this. lambda divided by 4 pi epsilon naught r. So that is your total electric field near this end. Okay. So if they give you this kind of charge, you know how to find the electric field. So just memorize this formula. So if you memorize this formula, you can do for any point and you can do for any uh, line charge, whether it is finite line charge or infinite line charge, you can easily find the angles, okay, and then you can substitute, okay. So some more applications we will do as we complete this chapter. We will start MCQs. So that time we will be doing more application of this kind of formula, okay. So now the next, this is your fourth distribution. Now fifth distribution of charge, I will give you arc of a wire. So this is arc. So this is arc. Total charge is Q, and this length is let me write L right now. So lambda will be charged by length, right? Sorry, it went outside, right? Okay. So I give you arc of wire. Okay, arc of charged wire. Arc of charge, like this, you know, arc of charge. So I have given you arc. Okay, arc means part of a circle. So now I want electric field at the center. This is part of a circle and that circle will have a center. So I want to know what is the electric field at P. So electric field at P. Now here again derivation no need, but since you know the formula for line charge, no, you can make use of that. So if I give you a line charge, let us remember again. See, the more we write, the more we remember. Easily we will be able to keep it in our mind. Okay. So if you have a line charge, then at the midpoint, if I draw a line, then at this point, what was electric field? I wrote lambda divided by, tell me, 2 pi epsilon naught r sine theta. And what was theta? Either this or this. Remember, right? Okay. Now think this line charge is made into a arc. And this P is your this P. Then this R is this distance. So that R will be nothing but the circle. So first thing what you should do to find the electric field here is subtend this angle. Okay, subtend this angle at this point. Then you find the bisector of this angle. Bisector. Bisector means a line passing through this, cutting this angle equally. So this is the bisector. Once you find the bisector, direction will be this way. It will be along the bisector. See, just like here. Here I told you electric field is this way. Remember or not? Okay. So direction you have found how, right? So if I give you some other question, let's say something like this charge, and I want electric field at the center. Okay, then what you do? Forget this now. This is the center. So you draw this arc, this angle. From the two ends, you draw these lines to the center. Then you find the bisector. Then electric field will be this way. Okay. So once you know the electric field, what will be the formula? E equals to, exact same formula you can use, lambda by 2 pi epsilon naught. This r was this. Here that r will be radius of this circle. So you can write radius capital R. For radius, let us use capital R. Okay, you can write small r, no problem. Just remember what is small r. But so in this case, whatever is small r here, that will be the radius of this, radius of curvature of this arc. Okay, sine theta. So sine theta. Now be careful. You in the question they will give you this angle. This angle. So that angle is phi, let's say. But what angle we write here? The angle we write here is this angle. Half of this angle is half of this angle, right? Yes or no? So we want this angle. So this angle is how much? 5 by 2. 5 by 2. So here we have to write 5 by 2. And what is phi? Angle subtended by the arc at the center. So this is the formula for electric field. Direction we know. And if you want lambda, if you want to substitute in terms of lambda, how will you do? Total charge by total length. This length. No, and what will be this length? What will be this length? You know that arc length is what? Arc length is r into radius, right? Sorry, r into theta. You know or not, students? If this is a circle, then you want this arc s, and this is angle, this is radius. Then what is arc length? R into theta. So you can write this L now as R into this total angle, which is phi in this question, phi, or in this topic. So I write R into phi. So if you substitute here, what will be your E? E will be Q divided by 2 pi epsilon naught R square sine phi by 2 divided by phi. Sine phi by 2 divided by phi, because lambda is q divided by r phi, no? So in place of lambda I wrote q, and one r will come in the denominator, one more r is already there, so r square, and one phi will come in the denominator. So again, if you remember this, you can easily translate this formula for arc also. See how easily you can, find some ways to remember. Understood? Okay. Then there will be also something called disk of charge. Okay, but for that I think we will not do it today. We'll do it maybe in the next video. So let us now just recap all the formulas. Okay, so summary. Okay, summary. So first we did line charge, and we asked electric field at some distance a at this point, and the direction of electric field was this way, right? And this is your L, total charge was Q. So you know the electric field here, right? How much it was? I think 1 by 4 pi epsilon naught Q. Then I think there was L into L plus A into A maybe. Okay, you can check. So you can check this formula. I have done the derivation already. Okay, so just check. Okay, so keep it properly. Then second one, we took a ring of charge. Yes or no? We took a ring of charge, and whose radius was R, total charge was Q. At this distance x, electric field, where was the direction? Direction was this way again, because each charge produces electric field this way here, this will produce here, so total will be here, right? And if this is the ring, electric field here was something like this. Remember I told, so these components will cancel, this will add. And what was the formula for the electric field? It was 1 by 4 pi epsilon naught qx by root, not root, it was r square plus x square power 3 by 2. Then I told, if you go very far, x will be very large. If x is very large, r square can be removed. Then x square power 3 by 2 will be x cube. I think I took r that time, no? R here. So then this will be r, this will be r. Again, students, what symbols we use, it depends on us. And we saw the graph of this, right? It was having some maximum. Electric field had maximum somewhere, and I told you to find that distance. Okay, that is your homework for today. And the third one was, I took a line charge like this. Then at the bisector, if I ask, electric field is lambda divided by 2 pi epsilon naught r, this r into sine theta. What is theta? This angle. Right? And then I told you, fourth one, if your line charge is like this, and your point is somewhere here, then you find this angle alpha, find this angle beta, and electric field will have two components, Ex and Ey. Ex was lambda divided by 4 pi epsilon naught r sine alpha plus sine beta. Visible, right? Okay, just visible. And this is lambda by 4 pi epsilon naught r cos alpha minus cos beta. You can check the formulas. Okay. Then for arc number 5, let me write here. If you take arc, okay, then at the center, if they want electric field here, then it was lambda by 2 pi epsilon naught radius. R is the radius into sine angle subtended divided by 2. And what is this angle? Phi. This angle is phi. Okay. And here direction was along the bisector. Here also it was first find the bisector of this angle, then electric field is this way. Here I told electric field will be here because more positive charge is below. And you know from positive charge electric field will start. Right? So it will have both x component and y component. So these two are the components. Okay, so these many things we have done today. I know today we did not cover any board syllabus topic, but even entrance is important, right, students? You people are spending so much money not only for studying board level, right? Okay, so try to go through all of this nicely, okay, and try to remember the formula. So let us apply this formula. We have not applied this formula anywhere, right? So let us apply that formula in one of the question. So application of fifth formula, application. So imagine I give you a not full circle, semicircle. So I give you a semicircle and I want electric field here plus charge. Okay. So what will be given to you? Lambda will be given, radius will be given. That's it. So how to find? First you tell me the direction. So direction, I told you, the bisector of this angle, right? So from these 2 point ends, you draw this line. So this is your phi. And what is phi? Pi. Okay, and then you draw the bisector, then electric field will be along the bisector. So if this is x-axis, this is y-axis, electric field is along negative y-axis, right? If this is x, this is y. And what will be magnitude? Lambda divided by 2 pi epsilon naught r sine phi. What is the angle? Pi by 2. Phi is pi, no? This angle pi. Right? Pi. And sine pi by 2 is 1. Sine 90 degree. So this will be 1. See, you pause and write down, okay? Don't think I'm teaching fast. See, this is not live class. I mean, I'm not doing it face to face in a classroom, right? So it's not like once I finish it or once I rub it, you can't do it. Just go back and revise the concepts. Just go back and write the notes. So we'll stop for now, and next class I'll try to revise electric field lines. Today I did not revise electric field lines, so next class we will be doing that. But keep checking whatever has been done. Okay, in the EPL also you can read, or if you want to see how I've derived certain formulas, how I've explained certain concepts, then keep seeing the video. Okay, thank you.